Hi guys, welcome back to a Docker class 2. Guys, in previous class what we have discussed, I think we have discussed introduction of the DevOps, Docker. What is Docker and what is the use of Docker and what is the use of virtualization, what is virtualization, I think we have discussed a little bit. Okay. Still we need to be discuss some more on the two tools. We need to compare both. Okay. Then only we can understand easily little bit what is the use of Docker and what is the use of virtualization and what are the advantages with virtualization and what are the some more advantages with the Docker compared to virtualization. So today we are going to working with the Docker. First of all, we will see some commands and what is the uses of Docker. If you see some scenarios on the Docker, then we can understand easily what is the Docker and how it's working. After that, then we can go for comparison with virtualization technology. Then little bit easy to understand and a little bit easy to comparison in between virtualization and this containerization. So in last class, just we stopped at install and testing one hello world container. Okay, let me show you once again that how to install Docker and how we will run that test case. Then we will go for images and all. We will discuss that. Okay. Yes. Yes. Cloud DevOps.in and install Docker installation. Install that one. You will get that very old version. So that is better to install. Okay, guys. Let me show you the installation of the Docker. Yes. Docker. Docker. Okay. Yes. Step 1. Next. Yes, we are going to downloading repo. Now we are going to installing Docker CE Community Edition. After that, okay, yes, you can apply that Docker icon version and Docker version. Next, Docker info. Of course, we will not get here. We need to start the service. Then only this command will work. Without starting service, if you apply this command without starting Docker service, you will not get. You will Docker will ask a question. Is Docker daemon running? It will ask the question. Okay. At that time we need to understand. Whenever the Docker service is not running, that time only we will get that query from the Docker. That time we need to understand Docker is not running, or else you can go for cross-checking. Yes. systemctl status Docker. Systemctl status Docker. Now systemctl start Docker. Next, systemctl enable Docker. Then you can apply that Docker info. Okay. Next, before that, before that, you can check that rpm space hyphen qi docker or else rpm space hyphen q docker. Okay. So after installing docker, yes, the same command you can ask. After installing, you can ask the same questions. Okay, then so we will start that. So docker images, docker ps hyphen a, next docker full hello world, next docker run hyphen it hello world. Okay, by this one we will see either a docker is running or not properly. Okay, then we will go for next step. Okay, next docker search image name. Okay, so first of all let me finish this, then we will go for next step. So first you can check here rpm space hyphen qi docker hyphen ce. So package docker ce is not installed. Again you can apply that only docker what is that, rpm space hyphen q docker hyphen ce. Okay, yes, yum list hyphen installed grep docker hyphen ce. Guys, we didn't install that package. So for by yum list also we can get, yes, yum list hyphen available grep docker hyphen ce. That package not available. That package not available. So we need to install this package from the docker. See guys. So whatever we have requested these commands, here we are having two kinds of repositories. One is the default public repository, mrepo servers, and another one it's a public mean default OSs operating systems repositories. Here particular private software repository servers, repo servers. Private mean, for example, right now, just wait. So now what we are doing that install, this is our local machine. I mean that where we are going to installing that server, calling as a local server. Now we are trying to install that install docker hyphen ca space hyphen y. You can apply this one. You will not get. Let me clear. Yes, install docker hyphen ce hyphen y. See, what is saying that unable to find match. There is no spelling mistake. Docker DevOps space hyphen ce. There is no spelling mistake. But okay, unable to find a match docker ce. These command, whatever we have applied this command, These command gone reach to directly this server. This operating system. This operating system means the which server we are using. Inside that server we are having one OS. What is that OS? What is the command to know OS name? What is the command to know OS name? Yes, first of all set me that host name ctl set -host name d host docker host exec bash. Now see guys, now host name ctl you can apply. So you can find here which OS we are using. Operating system we are using Rocky Linux 9.3. Rocky Linux 9.3 we are using. These Rocky Linux operating system organizers who are going to maintaining, who are going to developing, or who are going to organizing on this Rocky Linux, they are having or they are maintaining some separate servers geographically from my location. Now my machine connected, this machine connected to internet. This machine connected to internet. That server also, the Rocky OS organizes servers also connected to internet. Whenever we apply the command, this command goes to this default Rocky Linux organizers servers. They are not having this OS. Which one? This OS not having in their servers. So that reason, yes, they are having. What they are having? They are having old version. If you try to install this one, which one? If you try to install this one, it will come. It will come with a very old version. With a very old version you will get. So that reason I am not going to install that Rocky. What is that? Docker CE. This is only Docker. The Docker software is available in the organizers OS, OS organizers servers, but it's very old, too old. I am trying to install latest version. So that reason what I am doing that. Yes, now yes, for example, this is Docker developers. Docker developers. Oh yes, just wait guys, just wait. Okay guys, if we apply this command, what will happen? Now it's trying to reach this operating system. This operating system means, yes, what is that? Cat space, one more command, cat space / etc os-release. This is also command. See guys. So this operating system means Rocky Linux operating system developers or organizers are maintaining their own server. For maintaining what they are doing, whatever they are going to developing new versions of packages, or what they are collecting the application softwares or whatever related to operating system, related to network, or related to apps, everything they are going to collecting and they are placing into their servers. So whenever you apply this command, by default this command goes to these repo servers. So right now what I am trying to apply that command, yum install docker-c. See what it will tell. Yes, it's saying that unable to find, or there is no matches, no one not matching to this word or this package, which means they are not having this package inside their servers. So that reason what we have to do, we can't leave now, we can't stop here now. So that reason who are going to developing, which software we are going to installing, Docker CE software we are going to installing right now. So these organizers, these app organizers also are developers. or those engineers, they are maintaining their own server. They are maintaining their own server. So we can download the software in our local machine. From the private software, private server softwares also we can download that. If we want to download or if we want to install from their own private servers, what we should have is they are providing one repo list, repository list they are providing. You need to download and you need to keep in this server. That location is cd/etc m.repos.d. This is the directory. See, these are the default directories related to Rocky Linux. Whenever we apply this command yum install docker or else any package, this command goes to these packages, this repo list. If you want to see that, just apply that vam rocky-repo. Yes. Just wait. We don't have that packages, so that reason I have installed. Now you can apply that one. See guys, whenever you apply the command, whenever we apply this command goes to before, okay, by default, okay. Whenever you apply this command, if this repository, what happened? Too much. We'll do that. We will continue. Okay guys, now what we are doing, so whatever we are having that repository, whenever we apply the command, which command? yum install the package name. Without downloading private repositories, if you apply the command goes to these servers. See, mirror list, base OS and base OS debugging repository, one separate server for base OS repositories. See, AppStream repositories and AppStream debugging servers. So AppStream source servers like this. These are the server URLs. Whenever you apply the command, if the command related to this any one URL, mirror list, the command touch to this URL, immediately this URL take that command and this URL goes to that URL or that server receive this command and it will process based on our request. Now, at present we are not having Docker repo URL. You can see here we don't have that URL. So that reason what we are doing, we are going to downloading. First we are going to installing mutils, device mapper persistent data and LVM to logical volume 2. We are going to installing these packages at present. Now take this one and install this one. It's very small. Now it's installed. Now you can. Now what we are doing that? Now we are going to downloading Docker CE repo. Now you can see. Just paste here. Now you can see guys. See. Docker CE repo. Before that we are not having that. You can see here. See. There is no Docker repo. Now if you apply this command, which command? Yum install Docker CE space -y. If you apply this one, yes, this command goes to this server. Which server? Now you can see that LL Docker CE repo. See, for Docker stable installation, for Docker stable CE community edition stable debugging URL. If you want to debug, if you have any problem, yes, you can debug with this URL. I mean that they are maintaining one server. For once again that Docker CE stable source. See guys, these are the servers for test cases, for test debugging. See, Docker CE test sources. Okay, nightly if you want. See, debugging. Now what I am doing that. Now I am going to applying that yum install docker -ce space -y. Now this command goes to this file. Now this command will touch to this file, or else this file will respond to this command. It will receive. This file will receive this command, and it gives the permission. It gives the permission to that particular repository or stable version. CE Docker Community Edition, stable edition, stable version. It will download. Now apply that. See, now it's going to downloading. You got it now? Now we are going to downloading. Now we are going to downloading from this private Docker registry. Guys, you got it now, my point? Guys? Hello? Are you audible me?
Yes.
Okay.
Yeah, yes.
So you got it now?
Yes.
Okay. I'm getting little bit issue with this word. So that reason I'm not going to using that. Okay, just wait guys. It's going to installing. So this concept related to package management, whatever I have discussed right now, that's related to package management in any OS. If you are using Windows, yes, that is also belongs to software management server. Okay, and if you are using Windows or if you are using Linux, like that. Okay guys. Okay guys, successfully we have installed. Now we can check that rpm space -qi docker. If you apply that only docker, you will not get command not found. You need to apply CE. See, we have installed Docker. Now coming to the Docker description, what the developer said, yes, they are saying that, see, Docker containers are both hardware and software platform. Okay, agnostic. This means they can run anywhere. We can run anywhere. Once you install this one, we can run anywhere on any platform, Windows platform, Linux platform, or desktop or server-based OS. Yes, wherever yes you want to run that on desktop OS and server-based OS also we can run. Okay. Now we have installed. So by this command you will get this much of information. But if you remove this I, you will get a single line message. See, package we have installed successfully. Now system CTL status Docker, only Docker here. If you come into Docker service, you only apply that Docker, don't apply that -ce. For installation, if you want to see that either installed or not, or else if you want to install, you should apply that -ce. After installing, if you want to work with Docker, you should apply only Docker. Okay, now see guys, it's it. This is the location, Docker service location, and it's in inactive, dead mode. Now what we have to do? Yes, already I have written here the commands. Okay. Now what we are doing? Yes, you can see that. Okay. Yes. Docker version. See. And one more command you can see here. Cannot connect to the Docker daemon. This is asking that is the Docker daemon running? Daemon means service. So that reason only we got some information only. Few information we got from the Docker command. If this Docker service running, yes, we will get some more information. Now we are getting only client information. Docker having two parts. One is the client, one is the server. Docker server and Docker client. Now we got the information from the Docker client. If the Docker service running, we will get one more part. See, this is the point. Whenever the Docker service is not running, you will get this message. Now, so what I'm doing that I'm going to starting the service. systemctl start only Docker. Only Docker. Now you can apply the same command. See, now we didn't get that right now. Okay, system not asking us, is Docker daemon running? See, this is the server information. This is the server information. This is the Docker client or Docker, okay, client engine information. Now, systemctl status Docker. See, it's running now. Now apply that Control C. Now from next time, whenever you reboot the mission, whenever you reboot or restart the mission, again you need to start this service. Again and again you need to start the service. If you don't want to start the service, systemctl start, enable Docker. Just apply this one. It's enabled. You need not to start on every reboot. Okay. Just now clear this one. Now we have installed and started service. Next, coming to this one over, and now we are applying this command. Sorry, I forgot this one, applying before starting the service. Of course, already we saw that. Is your Docker daemon running? We will get that question from the Docker. Without starting, if you apply this one, we will get that question. Already we saw that for this one. Which one? Docker version. Okay. And if you apply that only, we will get one single line message from the Docker version of the Docker. Now you can apply this one. You will get that. Yes. Now Docker info. See, by this one we can see operating system information. This is the complete operating system information and the kernel hardware resources. How much we have given that RAM and the processor. Memory we have given that 16 GB, but right now it's available is 15.33. Yes, free space -h is a command to get the details of memory. See guys, 15 GB total we have given 16 GB. Remaining one, right now we are seeing here only 15. Remaining 1 GB is hide by operating system. So used only, right now we use that is 744 MB. Remaining free. See, shared and buffer and cache. See, okay, total we are using right now 14 GB, still 14 GB available space. Okay, it's the swap memory. We will discuss later on that what is the swap memory. Next, coming to, see, this is the memory and the processors. If you want to know the given processors, LS CPU. Okay guys, LS CPU. Okay, how many we have given? 8 processors we have given. CPU family 6 version. See, model 44. See guys, sockets. 4 processors we have given 4 into 2, 8. Okay, like this. This is the information. Same that information we got from the Docker. Docker will collect information about our operating system, and we are using that Rocky Linux. Already we saw that. And kernel version. If you want to see that kernel version, yes, uname -r. See guys, this is the kernel version. If you want some more information, uname space -a. See, platform, is it Windows or Linux or Mac or something? Yes, we are using Linux. Dhost, operating system name, the server name, host name. See, the same name here. And kernel version. Okay, GNU. GNU. Okay. See guys, this is the architecture 64-bit, 64-bit and 32-bit processor. And this is the kernel version. Yes, we will get this information by which one? By the Docker info. See, ID. Okay, Docker root directory, debugging false. We didn't apply that. Experimental, we didn't apply. Okay, insecure registries, present we don't have that. Okay, it's a local IP. Next, okay, coming to Docker, coming to some Docker. See guys, server side. See, this is the Docker information. Okay, Docker build X. Okay, Docker incorporation, version, path, compose, Docker compose we don't have at present. Okay, next, Docker compose, this is the version. Okay, already we got this one also. By default now Docker providing Docker compose also. Okay, but we need to configure that one. We need to configure that one. Guys, are audible me? Next, see guys, so containers are coming to server side. Containers, running containers 0. Already we have applied that Docker ps command. So what is the use of command? Yes, this command used for to list or to see the running containers only. Only running containers. Only running containers we can see that. See, here we can see that how many containers are running. This is the total containers. Total containers list. Running. We are having 3 types of containers. One is running containers, paused containers, and stopped containers. See, at present we are having 0 containers because there is no container. There is no container. So here we don't have any kind of containers. Next, coming to yes, this command. Okay, by this command we can see or list all containers. Containers also means running, paused, and stopped containers. Okay guys, at present we don't have any kind of container. Okay, now see guys, next, images. Here we don't have any image. The command. Now if you want to see that, yes, this is the command and it used for to list images from the local engine, Docker engine or local registry. Registry nothing but a repository. Guys, registry nothing but a repository. Now, okay, see guys, now let me show you practically. Yes, first of all, Docker images. See, nothing here. Next, Docker ps. No one not running. No one not available in the running list. Next, Docker ps -a. Here also, no one not available. No one not mean running container is not available, stopped containers are, and paused containers. Yes, here we need to discuss about this one. Guys, it's very, very important. Guys, is a very, very important concept. Keep in mind. Keep in mind. Without image, there is no container. Without image, there is no container. Without image, we can't create container. We can't see that running container. We can't see that paused container. We can't see that exited container. It's a blind word. Blind information. Without image, there is no container. It's not possible to create a container. Now we are seeing that. Yes, I'm moving to OPT. Okay, so now Docker images. See, here we don't have any kind of images. Now how we can see Docker ps-a. See, whenever you are seeing this, whenever you are seeing like this, it means no one not available. It's empty repository, empty registry, empty Docker registry. Here we are having three kinds of registries, Docker registries. One is public, one is public, and another one is private registry. Private registry. Yes. Private registry. For example, private registries. For example, yes, we can use Nexus repository. Already we are having idea. Nexus repo also we can use, and we can use that JFrog we can use, and GitLab we can use. Private registries, and this is the public registry, that is the Docker Hub. That is the Docker. And local registry. Local registry. Local registry means our local server. Local server, wherever we have installed Docker, that server or that location calling as a local registry. At present, just now we have installed Docker. So that reason we are not seeing any kind of images. By default, we will not get any kind of images by installing Docker. By installing Docker, we will not get any kind of images to local registry. Now what we have to do? You need to develop your own image, or else you need to depend on some other one. Some other one means, see guys, at present we don't have any kind of images in our local machine. Now what we have to do? We need to depend on either private repository or public repository. Coming to private repository, at present we don't have any kind of our private repositories. You don't know how to develop, how to configure private repository, and you don't have any kind of URL access. You don't have any kind of access to that private repository. Of course, private repository is there, but you don't have that access. If you have that access rights, yes, you can pull from the private repository. Okay, forget about that. Present, we don't have that private repository. Now what we have to do? We need to depend on public repository. We need to depend on public repository. So what is that public repository? Yes, let me show you. Yes, Docker Hub. Just wait. So you also should have this user account, guys. I'll tell that. Okay. Yes. So this is my username. I'm logging into this Dr. Hub. See, guys. These are my private registries, repositories. This is the username and this is the repository. This is the username repository. See, these are my own images. These are my own images. But these all are images in the public repository only. These all are under public. Everyone can download. You can also download these images. You can work with these images. See. Okay. Now, if you're coming to explore, see. Now you can see all kinds of images. All kinds of images. Okay. Available. Available mean recognized by Docker Hub. Recognized by Docker organization. 10,000 above images are there. See, Ubuntu image, Python image, BusyBox, Nginx. See, guys, all fine. See. Okay, Linux with the complete package index and see. Python. If you want to directly, if you want to work with Python without installing, just download this image. You can create one container. You can see Redis. Okay, PostgreSQL. Okay, see like that. So many HTTPD, Node.js, see MySQL, MongoDB. Okay, like that. So many. Say Docker. Docker in Docker. If you want to work with the Docker, just you can download this image. See MariaDB, like that. So many. Now our requirement is I want to download test image. Hello iPhone world. See hello world. An example of minimal Dockerization. What it gives us? It gives the information just for a test case running. See, sample tag. Okay. Now, if you want to download this one, just click on this one. Tags, just pull this one. Docker pull. Yes. Now coming to commands. Okay. Now, Docker search. Docker search is a command. This is a command. It used for to test our Docker software working or not fine. If you want to see by image, that is the image. Oh, sorry. Docker search. Okay, this command used for to search the image is available or not in the Docker Hub registry. In the Docker Hub, which image you want. Okay, just now let me show you the command. Yes, now Docker search hello world hyphen world. See. Now you can see, guys, this is the problem here. Actually, it's under, okay, now we got that in 2 lines or 3 lines like that. So if I decrease the font size, I think yesterday I told you that. Now you can see that. I'm going to reduce it. Yes, I'm using that 10. Yes, now you can apply the same command. See guys, in single line, you can understand easily. See guys, this is the image and it is certified by Docker Hub. It is official. This image belongs to Docker Hub organization. See, remaining all are belongs to private persons. Private or public persons. Someone uploaded with the name of, this is the username, this is the username, this is the username, like this. We can also upload this one. We can also upload this one. We'll see that whatever we are having our private images in the Docker Hub, we can search by this command also. Now let me show you that if the Docker is working or not. Fine. Yes, Docker. Now what I'm doing that I am going to pull in that image. Yes, sorry, this command Docker run -it hello world. Now, okay, Docker pull hello world. Now we are pulling that image. Now Docker pull hello world. See guys, using default tag latest, it's pulling from library / hello world. We got it now. Now you can apply that Docker images. Now see, we are having one image. It's created almost 8 months ago. And the tag is latest. Repository nothing but image name. Repository nothing but a image name. Here also we are seeing that now images. See, this is the repository. The same name. It is one repository. It is one repository. The every repository should have that username, except Docker Hub official images. Except Docker Hub images, remaining everyone should have their own username. Username is login username. See, this is my username, login username. For every user, we should have for every image we should have that image username before image name. It's calling as a complete repository. It's calling as a complete repository. This is one repository. This is one repository, like this. You got it now? Now see here. See, this is the Docker official image. So that reason here we are not having that username. Okay, now what I'm doing that I'm going to running that image. Without image there is no container, guys. Keep in mind. Now Docker PS, you can see running. If you want to see the running containers, this is the command. Under Docker PS -a, this command used to list or to see the all running containers, paused containers, exited containers. At present, we don't have any kind of any container, paused containers, exited containers, and running containers. Because just now we have installed this Docker. After that, we didn't download any image and we didn't run any image. Of course, just now we have downloaded one image, latest version of that. What is that? Hello world. Now we are checking that is Docker running or not properly in our local machine. Docker is the parent command. Now option Docker run. Docker run. Now Docker run. Okay, here run is the command. Run is the command, optional command. Okay, this used for to create a new container from existed image. Without image you can't create container. Okay guys, without image we can't create a container. Now here we are having image now. We are having image, hello world image. Now what we are doing that? Now we are going to creating a container. Run is a command, that command used for to create a container. Run is a command, that command used for to create a new container. Now you can, so first of all list your images. Spelling is important. Now Docker run -it, and this is the option we will discuss later on that. Okay, -it space image name, hello world. See guys, this, by running this image we will get some information from the Docker image. That Docker image belongs to the official Docker organizers. Those organizers are saying this one. Okay, which means our Docker service is running properly in our local machine. It will certify. By running this image, we will get one certification on our Docker service. Whatever we have installed in our local machine, it will decide either working or not properly. It gives the clarification. Now it's working fine. Now you can see that Docker PS we don't have running containers. Now you can see that the Docker PS -a, see, exited. That command what it will do, that whenever you run this command like this, it will run that container and it will pass the message and it will exit from the running state. It will exit from the running state. Yes, here you need to keep in mind, container nothing but a VM. Container nothing but a one kind of instance. Container nothing but a one server. But in Docker terminology, we are calling as a container. If we go to virtualization technology, that's calling as a VM, virtual machine. If we go to AWS technology, AWS cloud, yes, they are calling as an instance. If you go to physical machine, that's calling as a one server. If you go to Azure cloud, yes, they are calling one VM. But in Docker terminology, we are calling as a container instead of calling VM or instance or server. But that container also working as a one server. How we are going to working with instance, how we are going to working with VM, or else how we are going to working with the direct physical server. Same like that it will work, but it will work as a virtually. This is also one virtual container. This is also software based container, software based VM. But you need to call, or we need to call as a container in the Docker terminology. Keep in mind. And this is the information about the container ID, the base image by which image we have created that container, and the command. This is the default command by the Docker hello world image, and when it was created, and the state of the container, is it running or paused or exited. Okay, and it's not having any kind of ports, and name of the container. Okay guys, Now, see, okay, at present we are having, now, at present we are having one image, at present we are having one container. That container also in exited state. Exited state. Now you can see that at present we don't have any kind of running containers. But there's the test container testing the Docker software running state, is it working or not. For testing, like testing, we have downloaded that image and tested by running that one container. Now guys, so now what we are doing, now we are going to downloading our required images. So our requirement is, see guys, already you saw some DevOps tools for working with Git. You saw that, okay, we have installed one Git software in our local machine, either Windows or Linux. Same like that, if you want to work with the Git commands on the Docker console, you should have one container. Container and nothing but VM server. Yes, you saw that how to install Git on Windows machine, and you saw that how to install Git on Linux machine. If you want to work with any one software, you should have any one OS. Okay guys. Now, here also, if you want to work with applications, we should have that image. By that image, we are going to creating container. And here you need to keep in mind, it's very important, images are two types. Those two types are, one is the plain image, and another one is the custom image. Okay, guys, 1 minute, guys. Okay, guys. Okay, now what we are doing, that now we are going to working with our custom images. Images are two types. One is the plain image and one is the custom image. Custom image mean, see, already have that image. These all are my images. See, code build. Already we did this one, code pull, var build, image tagged. Okay. See, already we have developed this one. It's one website page, CentOS. If you want to work with the CentOS, yes, you can. See, guys. For example, if you want to pull this one, just take this one, click on that. Now click on that tags. See, guys. This is my custom image. Copy this one and come here. Just apply this one. See. But maybe we don't have any kind of packages inside that mission, inside this image. This is my personal image. Just a minute, it's going to downloading that. Docker pull is a command. That command is used for to download or get the image from remote to local. Now you can see that the Docker images. Spelling mistake. See, guys, here we are having. See, this is the official image. Every official image not having name. Name means tag. We need to tag. This is my username, and this is my image. Same. Now this is the size of image. Same like that. If you want to pull from the Docker Hub, public Docker Hub official image, that CentOS. Docker search CentOS. Yes, you can apply this one. See guys, CentOS. CentOS also OS like Rocky Linux, like Red Hat. See guys, this is the official image. Now I am going to pulling that Docker pull CentOS. Guys, see guys, images are two types. Images are two types. One is the plain image. Just imagine it. Now, just imagine it. This is one example. See, this is the plain image, plain paper. They are providing. They are providing. Okay, they are giving the feature to write whatever you want. Just imagine it. This is the plain OS. Plain OS. They didn't install any kind of packages. They are providing with minimal OS, bootable files and basic commands they are providing. Like imagine it, when if you are going to buying one newspaper, daily newspaper, is it custom paper or plain paper? Is it possible to write your content? Guys, is it possible to write your content on that paper? Or else are we going to using existed content? Paper is there, content also there. Inside that paper, the paper is the physical paper. That's the plain paper. Before writing that, now someone they have written the content inside that paper. That's the custom content. After that, they are sharing. Like that here also. See, here I have chosen that. Here I have chosen that one base OS. After that, I have downloaded. After downloading that, I have created one container. Container nothing but a VM. We'll discuss that. What is the image? What is container? We'll discuss later on that. See guys, Docker images. Now what I am doing that Docker run -it space CentOS /bin command /bin/bash. See guys. Now you can observe this one. Now your confusion started. From here. See guys, small observation. Before entering into the container, before creating and entering into the container, after entering into the container. This is after entering into the container, and this is before entering into the container. Before entering into the container, after entering into the container. Now, Docker commands won't work. Docker images. See, command not found. Because this is a new OS, CentOS. Now you can apply that cat space /etc OS -release. See guys, it's the CentOS. Now the cursor is in CentOS. It's mean now we are in another OS. See, this is the image. CentOS image in local machine. CentOS image. By this image, what we did, we have created one container. This is one container. Inside, now the cursor is inside this container. You need to come out from this container. If you want to execute Docker commands, If we want to execute this Docker commands, we need to come out from this container. Guys, once again, keep in mind, container nothing but that is also one server. You need to digest like that. Okay, you need to fix that. You need to fix that in your brain. Yes, container also one server. That is also one VM. That is also one VM. But it's the plain image. CentOS is the plain image. Just now we have created this image. You got it now? Now you can work with these OS commands and you can install whatever you want. If you want to work with OS commands, you can execute. You can install Git or you can install Java. You can install Maven. Yes, you can install whatever you want. Yes, blah, blah. Okay. N number of applications. It's mean it is also one OS. But, okay. How much is time taken to create container? See, Docker images. It's not working. Command not found because it's another OS. Now, what we have to do, we need to apply the command to come out from the container. To come out from the container. Okay, here we are having hard coming and soft coming. Hard command means, yes, if you apply that exit, yes, this exit command will kill this running container and come out from that. Come out from the container.
And the container having separate IP?
Yes, it's having. We'll see. IP space A.
And we can RDP also this one, no?
RDP. Yes.
Sorry. We can.
Yes, we can configure networking also. Okay, but it's an undercome bridge network. It's undercome bridge network. I think last night I have asked some questions to Spandana. Okay, and you are also, I think, Gopinath, you are working on that VMware. Okay.
Yes.
That network is little bit different. This network is different. And what is, whenever you are going to configuring network configurations with managed switch. Okay. IPv4, IPv6 VLAN. Okay. Static IPs, dynamic IPs, we are going to creating by managed switches now. We'll discuss later on that. We'll discuss that. Okay. This is the IP. Now, what do you want? Yes, if you want to come out from the container, if you apply that command, exit command, what it will do that? It will kill the container and come out of the container. Now, I'm opening that one more new tab. Yes, apply that root and command. So now this cursor, this prompt outside the container. Now Docker PS, see, it's in running up. Status mean up mean, it's mean the container in running state. Container nothing but that server, that VM, that instance are running. It's mean power on. Okay. Now if you apply this one, yes, apply that exit. See, exited. Now you can see that. See, now the cursor is in. Now the cursor in post mission. Now you can apply that Docker PS. No one not running. Same command you can apply here. Docker PS. See, but it's exited. Docker PS -A. See, 21 seconds ago it's exited. Okay. But if you want to if you want to come out from the container without killing or without stopping container, what you have to do? Yes, let me create one more container. Yes, Docker images. Guys, you can observe that how much it will take time to create container. Now, Docker run -it -it/bin/bash. This is the command. See guys, below 1 second, one OS, one server is ready. Okay, now if you want to come out from this container without killing or without stopping, okay, apply the control, immediately apply the P and immediately apply the Q without leaving control. You need to apply the first control. After that, you need to wait. You need to wait for 2 keys applying. After applying that, after pressing control key, you need to continue P and you need to apply the Q. After, you can leave the controller. Okay. Now see guys. Now Docker PS. One container is
Can
ready.
you explain again?
Yes, just wait. Yeah, Kandana, please can you repeat your question?
Can you please explain again, like how to
Come
leave
out
the
from
container with running? Container with running.
Okay, that's graceful. Okay, see now again I'm applying that. I'm going to creating one more container. See now the cursor is inside the container. Okay. If you want to come out from this container without killing, stopping, exiting, both are same. All are same. First of all, apply the control key from the keyboard. Don't leave that. Okay. Please continue. Please continue. After applying that control, apply the P. After applying the P, immediately apply the Q. Control P Q. Control P Q. Now you can apply that to Docker PS. See. Total containers. If you want to see that Docker PS -a. Total 4 containers are there. 2 are exited, 2 are up and running. Now imagine it. This is the image. Image developed by some other one. This image developed by some other one. Yes, after developing that image, who developed that image, they deployed into one public domain. They deployed into one public server. As a user, we have downloaded this image. As a user, we have downloaded this image from the public. See, this is the public repository. Docker public repo. We entered into this one. We have installed. Yes, this is our local server, local Docker registry. We have installed the software. Just wait here. Local Docker registry and Docker engine. Docker engine. And here we are having Docker server also. So after that, so what we did, we have downloaded this image from the Docker hub. With the help of Docker pull command, we have downloaded this one. After downloading this image into our local machine, so what we did, yes, we have created a container with the help of Docker run command. With the help of Docker run command, we got one container. See guys, while developing that image, what the developers have placed, what they have placed inside that image, the same things or else the same services we will get into this container. For example, just imagine it. You are going to preparing one item, or else just it's very best. Okay, now see guys, this is my image. Now what I'm doing that I'm going to installing Java, Maven, Tomcat, for example, yes, one var file, the var file, or else web data var file. Now what it is? So this is my Docker file. Or else let me show you that. So already we are having one report that this is. Just let me. Just wait this. Yes, Docker web application. See, this is my Docker file. Already have some Docker files. So it's a Tomcat, and this is another one. See, now what I'm doing that. Just come here. So VIM Docker file. Yes, paste here, and maybe so we need to modify this one. The latest version 9.0.84, I think. Let me modify that. Yes. Tomcat download. Yes, what is the latest version here? 9.0.85. Yes, let me copy this one and come here. Okay, yes, 9.85. You know what we are doing? 9.85. See guys. Now for this time we should have this one. Without this var file we can't develop. This is our developer. Now I am acting as a developer. Guys, now I am acting as a developer. This is if I develop, okay, if I run one command by this file, we will get our custom image. See, this is the base image, that's the plain image. We are pulling one image. Yes, these are the details of the author who are going to develop in this file or image. Yes, these are the mirror list. Now we are going to installing Java, we are going to installing wget, and we are going to installing VIM. Yes, if you want to some more, yes, you can. Yes, run yum install. Yes, git space -y. See. Now what we are doing that we are going to creating one directory Tomcat. We are entering into the directory. We are going to downloading Tomcat, and we are going to extracting Tomcat. We are renaming the Tomcat and moving the files into one Tomcat directory. After that, we are checking the Docker version and we are entering into the web apps. Yes, now we are copying this WAR file into this web apps folder. This web apps folder. Yes, this is the port number and we are starting the service. Okay, now let me delete this one. Okay, yes, save this one. Now see guys, this is Docker file. Now what I'm doing that Docker build space -t my image name. Which image I want that? What is that? Tomcat web server. Tomcat web server space dot. It's me. Now I'm going to developing that image. Whatever I have written or whatever I have mentioned, whatever I have placed the services inside that, the same application we will get, same container we will get. First of all, we will get image. Now what we are doing that we are going to preparing image. You got it now? Here I'm going to preparing with these services. After that we will get one image. Then what we are doing that by this image, with the help of Docker run command, yes, we will get one more container. So now I'm naming this one. So what I named that one? What is the name of the container? Yes, this one. That is the name of the image. See, now it's going to installing everything that is going to installing VIM right now. Okay. Now this is the image name. Now what I am doing that after getting that image, after developing that image, Docker run -it space container name. Which container? For example, if I want to my own container name, or else just contain -it space image name space command /bin/bash. See guys,
Why we use /bin/bash at the end?
we should have one command now. Shell command.
Why that command?
If you want to execute the shell commands, we should have one command. Or bash command.
No, I'm asking.
Yes.
Yeah, why that one command is used? Like, what's the use of that? /bin/bash.
/bin/bash is the shell. Okay. Linux providing. Okay, see, successfully we have created one image. Now you can see that the Docker images. See, Tomcat web server. This is the size. CentOS size is the 231. Base OS. After installing, what we have installed here? Just wait. So what we have installed here? We have installed Java and we have installed wget, VIM, Git. Okay. After that, we have downloaded Tomcat, extracted everything. Okay. After installing this one, yes, we are getting that size. Okay, this much size. Next, coming to why we are using shell. Cat space /etc shells. See. If you want to pass any one command, if you want to execute your task, we should have any one shell. We are using /bin/bash. Shell is the.
No, we are not using for every command, right? Like we are not using for every command /bin/bash. So why we are using only particular when we are creating the container?
Yes, We are assigning that command to that container. We are giving that command to container. Spandana, you got it?
No, I'm asking what is the, no, I didn't. So what's the use of that command to that container?
Sunita, sorry, Spandana, if you want to execute your commands, we should have any one shell. While creating that container, let me finish. While creating that container, we are giving this shell. Okay, this shell we are giving. Yes, in future I want to, yes, with that container. If I want to work with that container, yes, I need this bash command. I'm giving that container. Sorry, I'm giving that command to the container. Okay, you need to give any one command, or else by default it will take that. Now let me show you that. What is that? Yes, docker ps -a. See here, they have given that hello. You got it now? Command. They have given one command, but with that command we can't.
So what is the use of that command I'm asking? Like /hello/bin/bash.
Sunita, inside without a shell command we can't see. For example, right now what I'm doing that yum update -y. You got it now? What is this one? This is the user package. Sunita, you got it on my point? This is my user
No, I
package.
didn't.
Linux having, see, this is the Linux, sorry, this OS Linux. This Linux having here, okay, and kernel. It's the kernel and it is the hardware. See, the center one. This is the hardware. This is the kernel. This is the shell. This is the user. Whatever we are going to writing commands, the command goes to shell. Shell is the interface in between kernel and user. You got it on my point?
Is this concept before starting this, like creating the servers?
Sorry, come again.
So is this concept explained before creating all the server configurations, like before I join the class?
Your voice are not clear.
So I'm asking, is this concept explained before I join this class?
Yes,
Or
yes,
else?
yes.
Okay.
Okay, nothing to worry. This is the Linux basics. Okay, these are
Okay.
belongs to Linux basics. Here, now what we are doing as a user, we are applying that. Once you apply this command goes to shell. Okay, shell will take this command and it pass to kernel. You got it now? For example, cat, it's a command. Actually, it says it is also software. Yes, duplicate, that is also one software. Now we are applying as a user, we are applying the command. This command goes to shell. Shell will take and it will pass to kernel. Kernel it will take, it will try to execute that. Okay. For example, what I am writing that cat space /etc pass WD. Now we are getting this result. Who are giving this result? Who are giving this result? Kernel giving this result. From the kernel, we got these details. Okay, in between the kernel and the user. As a user, we are going to apply this command. As a user, we are going to apply that command. Now, once you hit the enter, the command goes to shell. Shell will receive the command and it will pass to kernel. Kernel will take the command and it will process the command and it gives the details, result to shell. Shell gives us. Got it now? We'll discuss later on that. Okay? But the command is mandatory.
But we are not using for images, right? Like while pulling the images or...
Ma'am, already they have given that. While in the image, while creating that image, no need. While creating that image, no need. While creating a container, you need to give anyone shell, either bash shell or p shell or k shell. Okay, for executing these commands. We'll discuss later on that. We'll discuss what is the shell, why we need to use that one. If we are not going to using that one, what will happen? We'll discuss later on that. Okay. Are they providing default shell? First of all, you need to know what is the importance of shell. Why we need to use a shell. Without shell, can we execute the commands or not? You need to know that first. Okay. Now see guys. Now Docker images. See. Okay. We got one image. This is our custom image. But coming to this one, this is the plain image. Nothing inside. Now what we did here? Now what we have installed inside this? Inside that we have installed Java, we have installed Git, and we have installed wget. Okay. Guys, you got it now? So now we have created. Now what we are doing that we are going to creating one container with our custom image. Docker ps -a. See here we don't have our own image. Okay, these all are by custom. By default CentOS image. Now what I'm doing that Docker run -it image name space /bin/bash. See, now this is our custom image container. Now, so inside that what we did, we have installed Java, we have installed Git, and we have installed Tomcat, and we have installed wget. Okay, and VAM also we have installed. Now you can check here. Yes, Java space -version. See, Java 1.8. Okay, next Git space -version. See, Git 2.27. 2.27. Next, we have installed Tomcat now. PWD, you can see that. See, and we have downloaded it. Yes, go back. ls-l. Here, like ll command won't work. You need to apply that ls-l. See, guys. cd/root ls-l. See, cd/opt ls-l. Got it now? So like this. This is our custom image. Custom image and a custom container. If you come out from this container, now Docker ps, now you can create, already we have container now. This is the CentOS container. Now let me enter into the existed container. Docker attach container ID or container name. Just now you can see that pwd cd/opt ls-l. Here we don't have anything. Here we don't have anything because that's a plain image. From the plain image. Okay, sorry, already we are having now. See, we have downloaded plain image CentOS. After that, we have created one container. Inside that nothing, empty. Now you can install whatever you want. Whatever you want, yes, you can install. Okay, but another method. So by the Docker file, you can develop your image. While developing that image, you can write whatever you want resources. After that, you can develop that image. Yes, you can go through that directly without installing any package. Because while creating that image, how the image will create Docker? while creating that Docker image, first of all, we should have one Docker file. That's a Docker file. By this Docker file, whenever you run that command, Docker build command, immediately that Docker build command will find the Docker file and it will pick the file. Then it will enter into that first command base. The first command base. Sorry. Yes, first the command enter into here. It will download the image. This is the image. From this image, this is the image it will download and it will write one author notification. After that, it will download that. It will create that repo links. After that, it will start the process. After that maintainer command, the Docker will create one container, empty container. Docker will create one empty container itself. The Docker itself only, it will create one empty container with this OS. It will download OS or image. Docker will download this image. After that, Docker only itself only, it will create one container on this OS, empty container. Then the cursor comes into this container. Then whatever we have written from here, it will execute one by one command inside that container. And so inside that, what we are doing that, yes, it will install that container Java, it will install wget, install VIM, and whatever we have installed and whatever we have written that commands, it will execute. After that, after doing all steps, the Docker what it will do that? Yes, it will create from this is the container right now. This is the container. Inside that container, Docker what it will do that? Already it did that. What it did, it's installed all required packages, whatever we have mentioned inside the Docker file. After that, the Docker will create one custom image. While running that image, while running that build command, whatever we have specified, whatever we have mentioned the image name. See guys, Docker build space -t, this is the given image name. This is our custom image name. By this image, by this name, Docker will create one image. After developing that image successfully, this container will delete Docker will delete that container, temporary container. After developing that image successfully, we can see only image. Only we can see the image. You got it, huh? Docker images. If you apply this one, we can see only our custom image, whatever we have given the name while creating that image. But we can't see that the temporary container which developed or which one created by the Docker. Docker will erase that image, container. After that, it will give only the image. By that image, you can do whatever you want. If you want to install additionally, you can install. You got it now? We will discuss later on that. These all are the little bit confusions from the Docker. First of all, you need to understand slowly. Okay, you got it now? We will discuss in next class. In today's class, what we have discussed, just forget about that Docker image building. Forget about our Docker own image creation, custom images creation, forget about that. Okay, in today's session, what we did, yes, we pull that one image and we pull that one CentOS image also. Docker pull CentOS. After that, we ran that command, Docker run -it image CentOS /bin/bash. So let me show you that. So whatever we have given that, for example, this is the base OS, cat space slash etc OS hyphen release. You can see here. This is the Rocky Linux. Now Docker PS. Now what I am doing that I am going to entering into this container. Here Docker attach is a command. This is the command, and it used for to attach to cursor. Okay, cursor mean we are attaching to Docker service. We are entering the cursor enter into that container. If you want to work with that container, if you want to execute the commands inside that container, we have to enter into that container. For entering into that container, we are going to writing Docker attach. But while applying this command, or else before applying this command, the container should be in the running state. Whenever you are going to apply this command, before that you need to make sure that the container is up and running or not. See here, if you try to execute that command on exited state container, now you can see that Docker attach. So which one in exited state? Yes, this is the exited state. Now you can take this one. Now you can apply that command. See, you cannot attach a stop the container. Start it first. Can you, small example, can you apply the commands or can you work with the shutdown laptop or shutdown server? Just imagine it. Right now you are having one laptop. Now what you are doing that you are going to shutting down the server or laptop. After shutting down, can you run the commands? Can you work with that laptop? Guys? The same one. That laptop equals to this container. This container equals to that laptop. Now it's in shutdown mode. This server is not working. First of all, you need to power on that server. You need to power on this container. That power on command nothing but Docker start container ID or container name. Container ID or container name. See. Now it's coming into running state. Now you can see Docker PS. See, just 5 seconds ago. See. Now you can say the same command. Which one? This one, no? See. So before that, before starting service, if you try to attach that one, what we got? You cannot attach. It's mean server not running in state. Not in that running state. Now it's working. Now here we are having two prompts, two terminals we are having. One terminal for container, one terminal for Docker host mission. Now free space -h. What is the RAM we have given? 15 GB. And LS CPU. How much we have given? 8 CPUs we have given. And what is the disk space? Free space F disk or LSB LK. See, we have given that 50 GB disk space. Total, we have given that 50 GB disk space. The same size, whatever we have given the RAM to host mission, the same RAM we will get into container. And whatever we have given the size of the processor, same size we will get. And whatever we have given the disk size, same size we will get into container. Now you can see that free space -h LS CPU, see 8 CPUs, and LSB LK. How much we have? 50. Now here how many containers we are having? Docker PS. See, now forget about this one. Oh, hello world, forget about. Right now we are having 4 containers. 4 servers we are having. Each server having 16 GB RAM. This is also 16 GB. 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 Now you can pick any one. See, now before that, yes, I have taken this one. I have taken this one. Now I'm going to pick in this one. Yes, I'm taking this one. Yes, apply that one. Now you can do free space -h LSB LK and LSB LK disk space and LS CPU. See guys, here it's mean whatever we are having here, whatever we are having containers, every container with 16 GB, 16 4 16 4 guys, 64 and 8 4 32 processors. 32 processors. Here total these 4 containers consumed 32 processors. Are we having 32 processors? No, we don't have. Here only we are having 24 processors. Now how is possible? How is possible? Okay. Now let me show you that one more. Just within 1 minute we will close, 1 or 2 minutes. Now Docker run -itd CentOS/bin/bash. Now something went wrong. Yes, we are inside the container. We are inside the container. Yes. Keep in mind, guys, if the command not working, command not found, it means simply understand the cursor inside the container. Container nothing but the server not having Docker software. So that reason we are getting. See, now it's created one container. How much is taken time? Now I'm applying that up and up arrow key and enter. See guys. That's enough. Whatever you are saying, that a long ID, that's one container ID. See, now you can see that Docker PS. See guys, how many servers are going? Can you buy this much servers within this time? Can you set up this much of environment at a time? Imagine it. These all are the servers, virtual servers. Now you can imagine it. How many servers are here? 2, 3, 4, 5, 6. Just imagine. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32 servers are there. Now you can calculate 32 into 8 processors and 32 into 16 GB RAM. Do we have that much of physical RAM? We don't have. And same time, do we have that much of physical processors? We don't have. But how is it possible? Now you can treat as a one mission for Docker. One is the for Jenkins master, one is the Jenkins slave, another one is the Jenkins slave for SonarQube, for Nexus, for application server, okay, for app server, okay, for one DB server, another one DB server, for one HTTP server. For yes, you can use whatever you want. Yes, for these are the yes. For 3 servers dev environment, for 3 servers QA environment, for 3 servers for test environment. Yes, next final one you can treat as for production environment. See, can you configure? Can you create this much of VMs in our on your physical this virtualization technology? We can't. That is the problem here. That is the advantage here. This is the advantage with the Docker, and this is the disadvantage with this virtualization technology. With this virtualization technology, finally, what is the final resources within the limit that should be servers maintained? Whatever the RAM is there, total 64 GB RAM. Within that, we need to utilize that. You can give for 64 VMs. You can give 64 GB for 64 VMs with 1 GB, 1 GB. Or else you can give for 64 GB for 1 VM. Once you give 64 GB 1 VM, you can't create second one. With 1 GB also you can't create. If you give the 24 processor for 1 VM, you can't create another VM with one single processor also. So what you have to do, you need to shut down the VM. Yes, you need to reduce the size like this. See, already I have given that 2 processors. Now what I am doing that? See, now I am giving that only 1 processor. And yes, here I have given that 8 GB RAM. Now I am giving that 2 GB RAM. See, now you can. But maybe these resources not enough for your application running. You got it on my point? These resources are not enough for execute your application to maintain your server. If you want to execute that application successfully and expected speed, you should have that resources. For example, just imagine it, if you want to execute one application, the application where you are going to placing and which server you are going to placing, the server should be reached with 8 GB RAM, at least minimum 8 GB RAM with 12 or 4 processors. At least the server should have that 4 core processors, minimum 8 GB RAM with 50 GB disk space. Then only your server will run properly. Otherwise, the server will get health issues, performance issues. Now you tell me, is it enough resources? No. These are the problems here. For avoiding these problems, you can install you can buy one laptop or one desktop or one high-end server. Just install the Linux directly inside that machine or Windows Vision. After that, install directly that what is that Docker inside that Windows or Linux machine. Then you can go for creating multiple containers. Whatever you are having physical resources, the physical resources, entire physical resources comes into this container. Okay, but each and every container works as a isolatedly. Every container works isolatedly. No one depends on another one. The dependency is only the host OS. That's the big advantage with this Docker containerization. So that reason why the industry peoples are, the business peoples are looking for this containerization, because of resources. And guys, imagine it, if you want to create this much of physical servers or virtual servers, virtual VMs or physical servers, can you buy these 32 servers at a time? If you go to one server, if you try to buy one server, it goes to 5 lakhs, 10 lakhs, 15 lakhs. Depends on your budget, depends on your requirement. At least if you calculate that 5 lakhs for one server, 30 into 5. Yes, imagine it. You want to buy that, you want to bring into your location, you want to collect the manpower, you need to recruit the manpower, and you need to buy additional resources. What is that? Devices, network devices, LAN cables, okay, like that firewalls. Okay, you need to buy some other, what is that? Extra what is that? Electricity, and you need to put that AC and all. You need to facilitate these all services. If you want to set up this environment, it goes to 15 to 20 days end to end. But here within the minute, yes, we have developed this environment. If you want to destroy this one, yes, Docker RM -F dollar docker ps -aq. Yes. See, within the seconds, yes, destroyed. Maximum hardly it's taken that only 5 seconds. Now you can see that docker ps, no one. Docker ps -a, no one. See how much it is easy. If you want to build it again, see guys. Yes. See, server creation, how much is taking time with the ready state. With the ready state, yes, docker ps. See, okay. Of course, not only this one, we'll see that. We'll see. Okay, some more advantages with this containerization. Okay, for maintaining these containers, yes, there is one. We are going to clustering these all containers. We are pulling all these containers in one cluster state. That's calling as a Docker swarm. But a Docker swarm little bit failed. Not a little bit, nearly 70 to 80% is no one not using that Docker swarm. But that's very, instead of Docker swarm, yes, we are using Kubernetes. That is a very powerful tool for managing these all containers. We'll see that. We'll see that later in tomorrow's class. Almost it's over, no? Time is over. Okay, guys. Thank you.